Hi everyone! Salamat sa inyong patuloy na pagsubaybay dito sa ating ginagawang discussion about statics of rigid bodies. Ngayon ay magbibigay tayo ng isang sample problem about the analysis of structure. And in particular, the method that we are going to use is about the method of joint. Guys, ito yung problem. Determine the force in each member of the loaded truss as shown. All triangles are equilateral. Sa ganitong klase ng problem guys ay kinakailangan muna nating ma-analyze kung paano natin sosolve itong situation na ito, no? So unang tanong ay ganito, no? If we're going to summarize the process, tanongin natin muna sarili natin, ano? Ano bang method ang dapat natin gamitin para sa problem na ito? Di ba? Dahil ang tanong ay, determine the force in each member. Definitely, it's very convenient to use method of joints because all members are to be solved. The next question it could be, can the analysis be started even without computing for the reaction at the support? Ibig sabihin ay, pwede ba tayo mag-start right away gayong wala pa tayong kinocompute na reaction? May mga cases kasi na kahit walang reaction, we can immediately start our computation. But in this case, we can check, is it necessary that we should first compute for the reaction? By looking at any particular joint na kung saan meron siyang dalawang members na nag-a-act, and we can apply right away the analysis of joint. Kung titignan natin, wala tayong nakitang joint dito, okay, na kung saan ay dalawa lamang ang members na nakakonect except A and C, where A and C are both support. Hence, reactions are needed to start the analysis because there is no joint that connects two unknown members except that those indicated as the support. Sa mga katuwid, kung ipapakita natin halimbawa yung reaction sa support, kunwari pinakita natin yung reaction sa support, itong next na tanong, how the joint should be analyzed one by one? Paano tayo mag-a-analyze ng method of joint? Saan tayo magsisimula? Alin ang kasunod hanggang sa makumpleto natin itong ating analysis? Kung titignan natin, we can start our analysis at either joint A or joint C, It's either joint A or joint C. At kung mag-start tayo sa joint A, the sequence will be the following, Okay, we can start with A, so that if we analyze A, we can solve for AB and AE. Then afterwards, tingnan natin alin ba yung mas convenient na i-analyze. Would it be E? Would it be B? O baka naman C? Kaya ang ating analysis ay nasa atin na rin, Tingnan natin mabuti, The next joint that contains no more than two unknown members ay E at C. Okay, pero dahil mas mabuti sana kung ang piliin natin ay yung mas simple lamang ang joint. Ang ibig sabihin simple lang ang joint, kaunti lamang yung forces na nag-a-act doon sa joint. At mapapansin natin kung dito sa joint E tayo, meron tayong 1, 2, 3, 4. Diba? Samantalang dito sa C, 1, 2, 3, 4 din. Pero mapapansin natin sa joint C, tatlong members dito ay may relation kasi meron siyang dalawa ay collinear at yung isa ay perpendicular. Kaya sa experience ko, it would be good to consider after solving joint A, I will be solving joint C. Kaya gamitin natin ang joint C, Kung mag-analyze tayo ng joint C, ang masosolve natin dito ay BC at CD. And then afterwards, pili ulit tayo, So we can select, either E or D. But in my case, simpler pa rin ang gagamitin ko. Ano may ibig sabihin ng simpler? Dun sa mas maliit lamang ang load. So dahil mas maliit lang ang load ng D, I would select D. Then if I analyze D, masosolve ko ngayon ang ED at ang BD. And then finally, I can now solve for joint E para masolve ko yung last unknowns. So ganun ako pag nagsasolve ng problem, ano, ina-analyze ko muna yung mga joint, papaano ako magsisimula, saan ako magsisimula, para kapag nagsimula na ako, tuloy-tuloy na yung aking magiging computation. Hindi ko na iisipin kung ano ba yung kasunod, sapagkat yung solution ay plano na in the analysis. So, ibig sabihin, I will be isolating joint A, then followed by joint C, followed by joint D, followed by joint E, after computing, of course, for the reaction. Di ba? Ngayon, pagkatapos nating ma-summarize yung analysis natin, we can now start with our solution. Ano? So, ipakita natin ngayon itong ating solution. At dito sa solution, meron tayong makikita na mga technique kung paano siya solve na mas madali. Bagamat, for the meantime, papakita ko muna yung usual process na ginagawa natin. Ano? Ito yung ating solution. Okay, so ipakita natin yung magiging reaction sa support, ano, dahil ito ay hinge support. Sa makatwid, meron tayong horizontal at vertical reaction. So, tawagin natin siyang AX at AY. At dahil ito ay roller support, ano ba ang direction ng force sa pag-roller? Ang direction ng force pag-roller, perpendicular siya dun sa support. Ang support natin ay ito yung ating plane. Sa mga katwid, ang reaction sa support will be in this direction. So, tawagin natin siyang reaction at C. At dahil siya nga ay naka-incline, so, this reaction would have horizontal and vertical. Ano? So, tawagin ko muna itong angle na ito. So, dahil nga ang angle daw ay equilateral triangles, yung mga triangles natin ay binubuo ng equilateral triangles. Sa mga katwid, yung angles that each of these, are all 60 degrees. Ito 60 degrees yan. Ito ay 60 degrees din. Ito ay 60 degrees din. Ito ay ganun din, 60 degrees, diba? Sa makatwid, itong C natin would have an angle also equal to 60 degrees with respect to the vertical. And this angle will be equal to 30 degrees. Kaya itong ating component ng C, CX at CY, may be expressed in terms of DC and the angle that DC is making with respect to either horizontal and vertical. Kaya itong ating CY will be equal to C sine of 30, samantalang itong ating CX will be C times cosine of 30. Di ba? So ngayon, kapag naipakita natin yung relationship between those unknowns as well as the other unknowns in the problem, we can now start solving for the reaction. Ngayon, tingnan natin mabuti, ano? Ano bagang nakikita natin dito? We have here actually system of non-concurrent forces in equilibrium. And so we can solve for AY by summing up AC, o kaya CY by summing up about A. Maybe we can start with CY, ano? We can start with CY. So, assuming natin na yung length ng sides ay L, kasi wala naman siyang given, pero since that is equilateral, we can assign any value. Let us imagine that all the sides are all equal to L. Lagyan natin ng values yan. Ito, lahat ng kanyang sides ng triangle ay equal to L. Kaya kapag nag-sum up tayo ng moments about A equal to 0 dito, equal to 0, masosolve na agad natin itong C sub Y. And once we solve for C sub Y, we can solve for C because C sub Y and C are related. And then afterwards, we can solve for C sub X because C sub X and C are also related. And then summing up all applying all other equations of equilibrium, then we can solve for AX and AY. So, ituloy natin, So, we will sum up moment about A equal to 0 and considering counterclockwise moment as positive. I am using here the sign convention for the moment sum. Shall be equal to 0, and from here, we can solve for CY. Let us now try to analyze, how are we going to come up with the equation? Here is C sub Y natin, at ang kanyang moment arm from A is twice 2L, so that is 2L. Whereas the next value will be for 8. What will be the moment arm of 8? That is L, and the direction will be clockwise with respect to A, and therefore that would be negative. That would be minus 8L. This 4 kilonewton, which is acting at E, would have a moment arm. Equal to 1/2 of L because it is equilateral. The line that will be drawn okay, to bisect perpendicular to AB will be equal to 1/2 of the distance AB, and that is equal to 1/2 of L. So that the moment due to this 4 will be equal to 4 times 0.5 of L. Whereas this one, okay, D, the force at D, which is equal to 2 kilonewton, would have a moment arm equal to the sum of this distance, 1/2 plus 1, which is equal to 1.5. If this will be multiplied by 2, that becomes 1.5 times 2, and the moment will be also a counterclockwise, hence that is also negative, and that is equal to 2 times 1.5 of L, excuse, shall be equal to 0. And simplifying, we can solve for C sub y, which is equal to 6.5 kilonewton. Now, after solving for C sub y, we can solve for C, because C sub y, okay, is equal to C sine of 30, this one. Now, from here, we will be substituting C sub y, which is equal to, okay, 6.5, and substituting the value, the function of sine of 30, which is 0.5. Therefore, we can solve for C. C will be equal to C sub y over sine of 30, and that is equal to 6.5 over 0.5. That gives us a value of 13. Now, after which, we can also solve for C sub x, because C and C sub x are related. That is, okay, C sub x equals C cosine of 30. Now, since we have computed for the value of C of 13, therefore, C sub x can be computed to be, okay, 13 multiplied by cosine of 30 actually is equal to the square root of 3 over 2. Okay, this is special angle, so even without calculator, you can solve for that, So that is equal to the square root of 3 over 2. Okay, simplifying, this becomes 6.5 multiplied by the square root of 3. So we already have computed for C sub x and C sub y. Now, applying the other conditions of equilibrium, we can solve now for A sub x and A sub y, So we have, okay, we will sum up moments about C. This time I will be using summation of moment about C. Rather than computing for the summation of vertical, I will use summation of moment, because if I'll be using summation of moment, then A sub y will be computed independent of the computed value of C sub y. Sabihin nun, kung nagkamali ako ng C sub y, meron pa rin akong chance tumama dun sa A sub y ko. Kaya I would rather use the summation of moment about C equal to 0. And the value will be, okay, the following, and we will sum up moment about C equal to 0, and using counterclockwise as positive, then our equation will become equal to A sub y, 8, this one, multiplied by L as the moment arm will be counterclockwise, and hence that is positive. This one, 4, will have a moment arm of 1.5 from C. Therefore, this is equal to 4 times 1.5 L. And this one would have a moment arm equal to 1/2 of L. And that is plus 2 times 0.5 of L. Okay, minus the moment due to A sub y. And that is whose moment arm is equal to 2L. That becomes minus AY times 2L. All of this must be equal to 0. When we simplify, all those L's will cancel, and we can solve for A sub y of 7.5 kilonewton. Meron lang akong gustong itanong sa inyo. Yung process ba ng pagkuha ng reaction sa A at saka sa C, particularly on the computation of the vertical component, ay madali lang para sa inyo? Definitely madali lang yan, kasi simple lamang naman yung moment equation. Kaya lamang, kung normal na computation natin, maaaring it will take us about 3 to 5 minutes to compute for that. Hindi ba ga? Pero alam nyo ba na with simple inspection lang, wala tayong gagamitin calculator, ay you can solve for A sub y and C sub y right away. So yung ating mga 3 minutes sa computation will be reduced to about 30 seconds. Malaking bagay yun na nakakapag-save ka ng time, lalong-lalo na sa board examination. So, paano yun? So, para maunawaan natin yung process on how to have a simpler computation and a faster computation of the vertical components at A sub y and A sub x, ay ganito. I will show you here some related concept on how you can simplify your computation. Okay, and this is some the technique that I am using whenever I solve problem, lalo kapag ganito yung situation na applicable itong konsepto na ipakikita ko sa inyo. Okay, here are some useful techniques in simplifying solution to determine reaction at the support. Ano yon? Ito yung isa sa mga konsepto na pwede natin magamit. Ano? A symmetrically constructed structure and subjected to symmetrical loading and whose axis of symmetry coincide with the axis of symmetry of the structure will have equal reactions at both ends. Ang sabi daw dito, no, kung meron daw tayong isang structure na symmetrically constructed at yung structure na yon is symmetrically loaded din, na kung saan yung axis of symmetry ng load ay nagko-coincide dun sa axis of symmetry ng structure sa makatuwid, yung load will cause for the reactions to at both ends to be equal. So, pakita natin, no, halimbawa, meron tayo dito isang simpleng structure, isang simple truss, which is symmetrically constructed. Ang ibig sabihin ng symmetrically constructed, yung dimension nito ay equal dito, itong dimension na ito equal dyan. Ibig sabihin, pag hinati mo siya sa gitna, okay, what you would see on the left would also be seen on the right. Kaya, assuming that this point is our A and this point is our B. Now, if this symmetrically constructed structure is symmetrically loaded. Halimbawa, ano bang isipin ng symmetrical load? Halimbawa, yung load na yan. Symmetrical kasi yung distance niya pareho, okay, from the center line. O kaya, ganitong itsura. Okay, symmetrical pa rin yan. O kaya kahit lagyan pa ng load dito, symmetrical pa rin yan. Ano nga yung ibig sabihin to? Kapag meron tayong symmetrical structure at symmetrically loaded, then the reaction at the support will be equal. Ibig sabihin, yung RA natin dito ay equal sa RB dito. And they will just share the loads on top of the structure. That means RA is equal to RB and that is equal to 1/2 of all those loads on the top, Since total loads is 8P here, then they will be sharing. Each of them will have 4P. Diba? So, ano pa? Ito pa yung isa sa mga magandang makita natin, no? Okay. A concentrated load at X distance from the support will cause a reaction at the support equal to the ratio of L minus X divided by L of the load. Medyo parang mahirap pa sundan, ano? Ganito yun. Halimbawa, meron tayo dito structure, ano? And these are supported with reaction at A and B. And the total span of the structure is L. Ito yung span ng L, ano? Ngayon, meron daw tayong load dito. Sabihin natin meron load tayo dito ng value P at ang distance niya from one support is X. Diba? Sa makatwid, ito daw A na ito will have a reaction equal to the ratio of the distance of this P from the other side, from the other support, that is equal to L minus X to that of the total span. Ibig sabihin, yung ratio daw nitong kay L over X divided by L of the P will be carried by A. So, makatuwid, RA natin will be carrying that ratio of L minus X over L multiplied by P. At yung kabila naman yung R sabi natin, will also be carrying the same ratio. Kaya lamang ang ratio naman, yung distance nitong P na ito mula dun sa other support, that is equal to X divided by L multiplied by P. Diba? Ngayon, pero tanong bakit ko ipinakita yan? Kasi, sabi ko nga, may mga situation na pwede naman nating solvein ang problem ng mas mabilis at mas madali even without the use of calculator. Kung magagawa natin yun, then we can simplify our solution at mas marami pa tayong problema na masosolve. Lalo kung ito halimbawa board examination that all the problems are talagang kinakailangan natin makarami tayo ng solutions ng solved problem. So bakit ko pinakita yan? Kasi tingnan natin balikan natin itong structure natin. Okay. So, we have here a symmetrically constructed structure. However, the loadings may not be symmetrical, But, if we are going to look at 4, if 4 will be divided into 2 and 2, diba? 2 and 2. Mapapansin natin that the 3 loadings becomes symmetrical. And the axis of symmetry will coincide with the axis of symmetry of the structure. Hence, due to this colored shaded loads, this vertical reaction at A and C will share each other. So that R sub A here will have a share of the load from the symmetrical of 6 kN as well as that of C. Maghahati lamang sila. Diba? So kahit wala ka ng computation, automatic alam mo, that's 1/2 of the loads on top. May natira pa lang 2. May natira pa ditong 2. Kung titignan natin itong 2 naman, ang distance niya will be what? Will be 1.5 of L from C, and whose total distance will be equal to 2L. Hence, itong R sub A will still carry additional load from 2 equal to the ratio of 1.5 over 2L of the value of 2, and that is equal to 1.5L over 2 multiplied by 2. Samantalang itong C naman will be carrying the portion of this K2 whose proportional will be the ratio of this distance. Yung distance naman niya from A, and that is equal to 0.5 of L of 2. That is equal to 0.5 divided by 2 of L multiplied by 2, and this gives us a total value of 6.5. So kung mapapansin natin, ganun mas mabilis nating masosolve yung problem. Imagine if you are able to do it this way, ilang segundo lamang yan, siguro mga 30 seconds lang yon. Kumpara dun sa nauna nating ginawa na it took us siguro mga 3 to 5 minutes to complete for the vertical reaction at the support. Diba? Ngayon, balikan lang natin. Kunwari, dito tayo nag-solve. So, we have to compute for the reaction at C. Okay? We have to compute for the reaction at C, where C is equal to, ito yung ibinalik ko lang yung relation, ano? Ang value ng ating C sub X natin dito, C sub Y, will be equal to C sine of 30. If C sub Y is already computed, we can solve for C, that is K13. And then similarly, yung C sub X natin will be C cosine of 30, and that gives us, okay, 6.5 multiplied by the square root of 3. And then we will be applying the summation force horizontal for us to be able to solve for this A sub Y or A sub X. And that is A sub X will also be equal to C sub X, and that gives us also a value of 6.5 K over the square root of 3. Then afterwards, okay, what shall we do? We can now compute K one by one the structure. Okay? Gaya nga ng pinakita ko, saan ba tayo mag-start? We can start with A or C, then followed by, if we started with A, then we followed by C, then we compute with D, and then finally at point E para ma-solve natin, ano? So let us now try to isolate joint A. Pakita natin, isolate natin yung joint A. Imagine natin that is our joint A. In-isolate ko. Ipinakita ko ngayon yung mga forces na nag-act dito, plus this one, okay? And the members, kaya na tinanggal ko dito, ipakita ko yung forces na ina-act niya. Ito yung force na yan, naman. So, mapasin natin that I have not indicated the direction yet of these forces. Ano? Itong force na ito yung ating AB, samantalang ito naman yung ating AE. So, again, sabi ko, wala pa akong direction kasi ang totoo, hindi pa naman natin alam kung ano yung direction. So, normally, ang ginagawa ng iba, okay, they are assigning the direction of this or assuming the direction of this, and their direction will just be checked by the sign of the resulting value. In some cases, instead of assuming, we can naman predefine. Makikita naman siya, and we can define how the direction of the force will be directed. Ba? Ganito yon. Para maintindihan natin, we always think of the condition of equilibrium na sinasabi, the summation of the forces along any direction must be equal to 0. Okay, pag-aralan natin, tingnan natin, since ang AB ay naka-horizontal, wala siyang vertical component. Ang makikita natin may vertical component dyan is AE. And we say that the summation of force vertical here must be 0. Since the reaction at A is already at 7 point directed upward, for the summation vertical to be 0, there must be a force that should be other force that should be directed in the downward direction. So, makatuwid, dahil wala namang panggagalingan na vertical component sa A, manggagaling lamang yung vertical component from AE. At ang sabi nga, for the vertical components to be 0, itong vertical upward na nanggaling sa A sub V ay dapat mabalanse ng vertical component ng A sub B. Sa makatuwid, A sub AE must have a vertical component that is directed downward. Sa makatuwid, kung directed downward siya, ano ngayon ang kanyang maging direction? It must be directed, okay, down to the right. Diba? Sa makatuwid, ganun din. So, kung ito ay down to the right, meron siyang rightward component, ito rin directed rightward. And we are expecting that the summation of force horizontal be 0. So, para maging 0 yon, dapat ito ngayon, babalansehin, kukontrahin itong component nito at itong rightward direction. Sa mga katuwid, ito ngayon must be directed to the left. Ngayon, itong tanong, since this is a truss, and we know that a truss is is composed of two force member. Na yung two force member na yun may either be subjected to tension or compression. Ang tanong ay ganito, paano ko malalaman kung ang force o yung member ay subjected sa tension or compression kapag gumagamit ako ng analysis of structure? Itong sagot, kapag ang direction ng force na nakikita natin ay directed towards the joint gaya ng pinakikita dito ng AB, ang ibig sabihin, AB will be subjected to compression. Samantalang kapag ang force ay directed away from the joint na gaya ng ipinakikita ng AE, therefore AE will be subjected to tension. Ganun natin na ipakikita. Okay, malalaman kung siya ba ay tension or compression. So ituloy na natin, So we now analyze and we solve for AE and AB. Ipakita natin itong mga angles na ito. That angle must be 60 and the other one will be equal to 30. Now, if we are going to sum up, sum up force vertical, we can right away solve for AE. So, we can sum up force vertical and assume natin ang force vertical upward is positive. From here, we can solve for AE. So, what will be our equation? We have here 7.5 minus the vertical component of A which is equal to AE cosine of 30 will be equal to 0. Now, if we're going to substitute the cosine of 30, which I believe may not need your calculator because this is a spatial angle that is equal to square root of 3 over 2. So we substitute the value. So 7.5 minus AE times the square root of 3 over 2 will be equal to 0. When this will be transposed, di ba? Yung 2 ay nasa numerator, then we cross multiply, that becomes multiplied by 7.5. Even without the use of calculator, AE can be computed to be 15 over the square root of 3 in terms of kilonewton, and since this is away from the joint, then this must be in tension. Ganon yung explanation. Now, afterwards, what shall we do? We can now solve for AB by summing of forces horizontal equal to 0. So we sum of force horizontal equal to 0. So we have, assuming that rightward direction is positive, and from here we can solve for AB. What shall we have? So we have 6.5, this one, minus the horizontal component of AE, this one, plus the horizontal component of AE minus AB will be equal to 0. So from here, we can solve for, we substitute the value of AE, by the way, which is equal to 15, the square root of 3, and sine of 30 is 0.5. Minus AB shall be equal to 0, and from here we can solve for AB to be 9 the square root of 3 or equal to 15.588 and directed towards the joint, therefore this will be in compression. Diba? So okay na, nasolve na natin itong AB at saka AE. So we now move to isolating joint C. So we isolate joint C. So when we isolate joint C, kunin natin ito at take that part here. Then we show the forces acting there. Then we also show this force acting, the reaction actually, to the right at C. So, and then we show the forces exerted by BC and CD, which are taken to be this way. Again, ganun din, wala pa rin ako pinakita. Ito yung ating BC at ito yung ating CD. Wala pa rin ako pinakita ditong direction, pero we can predefine that direction. Paano nga ulit? Itong force na ito ay upward. Sa mga katuwid for the summation force vertical to be 0, dapat mayroon pang another force that should be directed downward. At ang panggagalingan lamang noon ay itong CD. Sa mga katuwid CD must be directed down to the left. Mayroon siyang downward component, therefore that must be down to the left. At kung titignan natin yan, itong may leftward component na ito leftward directed, therefore it must be directed to the right to make the condition of equilibrium satisfied. Therefore, that becomes equal to directed this way. And because it is directed towards the joint, therefore, we expect that this BC will be in compression, and CD, because it is away from this joint, therefore, it must be in tension. Now, we now apply. We now try to show the angles. This angle is 30 degrees as 1/2 of this one. Ito yung part nito. Therefore, when we sum up, force vertical equal to 0, and assuming that upward direction is positive, therefore, what do I have? I will have 6.5 here plus, minus the component of CD, okay, cosine of 30 shall be equal to 0. And therefore, substituting CD again, okay, to be at the square root of 3 over 2, okay, and then that will be equal to 0. Therefore, from here, we can solve CD as 13.5, 13 divided by the square root of 3. And again, since it is away from the joint, it must be in tension. And afterwards, we sum up force horizontal equal to 0. And from here, we can solve for BC. We can solve for BC. Assuming natin that rightward direction is positive. So what are those rightward direction? I will have here BC. Okay, BC. Minus this one, 6.5. Minus the horizontal component of CD, which is equal to, okay, CD sine of 30, and that must be equal to 0. So from here, we can solve, substitute natin yung value ng CD, ano? Okay, which is taken at 13 over the square root of 3 multiplied by sine of 30 is 0.5. So we have here 13 the square root of 3 times 0.5 shall be equal to 0. And so that BC will be equal to 15.011 and directed towards the joint. Therefore, this will be in compression. Okay? The next is we isolate joint D. Yan, joint D natin. We isolate joint D. Punta natin joint D and we show the forces acting 2 kN. The value that we have taken for C is already known. We just have taken that, and it is already in the form of a tension whose magnitude is 13 over the square root of 3. So you have to already show, when you isolate, when this is already known, you have to indicate what would be the sense if it is in tension. So you indicate that this is also in tension. And then you show the other two forces there, which are indicated in that direction. Here is our BD and the other one is our DE. Diba? So itong tanong dito ba sa joint na ito, pwede rin nating ma-predefine yung direction ng BD at DE para hindi na tayo nag-assume. Okay? Tingnan natin paano, no? Itong given na ito na 2 kN at ito na CD, dapat meron siyang relationship at yung effect nitong dalawa, babalansin ito. Okay, sa tingin ba natin, alin ba yung mas malaki sa dalawa? Di ba? Mas malaki sa dalawa. Itong angle na ito na this CD is making with respect to the horizontal or vertical is, itong angle na ito is 60. Sa mga tuwid, itong CD is, ang component ito in the vertical direction is, okay, CD times sine of 60. At ano ba yung sine of 60? Ang sine of 60 is the same as the cosine of 30, which is equal to the square root of 3 over 2. Sa mga tuwid, square root of 3 over 2, magkakancel lang yung square root of 3 dito. Ibig sabihin, itong vertical component ng CD is 6.5. Sa mga tuwid, kung 6.5 itong vertical component na ito, tapos ito naman ay 2, mas malaki ngayon yung pataas. Di ba? Hence, dapat mabalanse siya ng downward component na manggagaling ngayon sa BD. Ang BD ngayon dapat natin, nasa natin is directed down to the right. At dahil ito ay rightwards din, so makatuwid itong DE will balance the rightwards components of CD and BD. Hence, this must be directed to the left, okay, so that this becomes subjected to tension. Di ba? Pakita ngayon natin yung mga angles. This is 60, this is also 60. Therefore, if we will sum up vertical equal to 0, so what do we have? Assume natin that upward is positive, and so from here, we can solve for BD. And what will be our equation? Unahin natin itong, okay, CD sine of 60. Ayun. Okay. Minus this one. BD sine of 30. Sine of 60 minus 2 shall be equal to 0. If we are to substitute CD, which is the square root of 13, the square over the square root of 3. Therefore, we have, and also the sine of 60, which is the square root of 3 over 2. Diba? Minus BD multiplied by the square root of 3 over 2 minus 2 shall be equal to 0. Sabi ko nga, itong dalawa na ito will cancel each other. So, matitira dito, 13 divided by 2 is 6.5 minus, okay, 2 is 4.5. Pag i-transpose ko ito, that becomes BD square root of 3 over 2. And then, pag sinimplify ko yan, lalabas yung BD is what? 9 over the square root of 3, and the direction is, okay, towards the joint, hence this is in compression. Di ba? Or 3 multiplied by the square root of 3 because I rationalize, okay, the square root of 3. Now, from there, we apply summation of force horizontal para masolve naman natin itong DE, itong part na ito. Assume natin that rightward direction is positive. So, what do I have? So, I have BD cosine of 60 plus CD cosine of 60 minus DE shall be equal to 0. And so, if we are going to substitute cosine of 60, which is equal to 0.5, ano? BD is computed to be, okay, 3 over this, 3 times the square root of 3 times 0.5 plus CD, okay, which is the square root of 13 over the square root of 3. It's already computed here, ano? Multiplied by 0.5 minus DE, or shall be equal to DE. Therefore, DE will be 6.351 in tension. So, nasolve na rin natin itong part nito. And then lastly, we can solve for the last member, BE, by isolating joint E as FBD. So, when we isolate that joint E, so here is the member. Meron tayong 4 dito. Yung ED is already known to be at 6.5, also in tension. Unahin natin yan. So, in tension na siya. And the value is 6.351. And then we show this part. Okay, and this will be already known also. Okay, because this is already computed, ano? In the previous one, and the value is K 15 over the square root of 3. Then finally, we can solve for this. And this is our, okay, BE. So, define natin to because, okay, this is directed upward. Therefore, it will be balanced by a downward component coming from EB. And you have this value. This angle is 60. So this angle is 60. So, we can solve for this BE by summing up forces vertical equal to 0, then upward positive, so you can solve for BE. So, we have here AE sine of 60 shall be minus BE sine of 60 shall be equal to 0. I'm sorry, minus 4 pa pala, ano? K shall be equal to 0. And so, from here, we are going to substitute the value of, sorry, this is AD, this is AD. So, we have the following, 15 over the square root of 3, yan, minus 4, and so BE will be 4.0417 041 kilonewton, and the direction is in towards the joint, therefore that is in compression. Diba? So, guys, yan ang process ng paggamit ng method of joint in analyzing the structure. Kaya sana ay nasundan ninyo yung mga discussions natin at lalong-lalo na yung mga techniques na nakita natin pag-solve ng reactions. Ano? Okay, how are you going to simplify the reaction in solving for simplify the solution in solving for the reaction at the support. Thank you for watching.